We're ready now to talk about confounding, or common causes, which I think is a little bit more intuitive of a name, graphically. So we get to explain, we've seen a lot of examples. I've talked about it in generalities. I just want to show you what it looks like graphically and then tell you just up front what the solution is. So let's say we're doing an observational study. For example, we are looking to see whether a heart transplant affects the number of survival days. And unfortunately, we know that the treatment is governed by the severity of a disease that is unmeasured. We don't measure it at the time. And we can also, we've asked the doctors, we also know that the severity of the disease also affects Y. So it affects the outcome, the survivability. So in this case, if I want to go ahead and write this out sort of in a linear way, I would know A is affected by U, some unmeasured severity of the disease, which also affects Y. So A is associated with Y. Even though in the diagram above, I have not, so absolutely no causal effect. Okay, we can call this a backdoor path because there's no direct causal effect in this case going from A to Y. So there's none of that, so I'll take that away. So there's no front door path from A to Y, but there is a backdoor path, which is through a common cause. So U causes A and U causes Y. As we've talked about before, there's only one solution to this. Well, two solutions. One is to give up, and then two is to turn this U into a measured and conditioned upon confounder. If we can condition upon U, then we can assume that this backdoor path is blocked, and then A and Y are no longer associated. So the solution to confounding is very simply measure. So you need to measure this unmeasured confounder and condition. So measure and condition. Now I want to caution you. Remember, we talked about before that one other cause of having association not be causation, so a violation of exchangeability, happens to be conditioning upon a common cause. So if you measure and condition upon everything, that might actually introduce association equals causation. It might actually introduce bias into your model. You need to be very careful about what you condition upon, and generally it's best to have an expert in whatever field that you're working on in the room. So for example, if you're working on medicine, you'll have an expert doctor in the room that can tell you whether certain things might affect other things in specific ways. You'll be able to make an elaborate causal diagram, and you'll be able to tell what affects what, at least from an expert's opinion, and measure and condition accordingly. So to give you guys a lot of intuition into confounding and common causes, I'm going to go over, I think, 3 or 4 examples, graphical examples of common causes over the next couple of videos, and show you how you would condition upon them to avoid having common causes in the first place.